Dear students, I am Dr. Rajiv Sapre. This is the 21st audio for you. In this particular audio, we will talk about trigonometry again. In the last audio, I have told you that when the angle is in a particular quadrant, then you can decide the signs of the trigonometric ratios of that angle. And for that I have told you that the word add sugar to coffee you should remember. These 4 words or this sentence when you remember, you will get the signs of trigonometric ratios. So when the angle is in first quadrant, then all the trigonometric ratios are positive. When angle is in second quadrant, sine is positive. In third quadrant, tan is positive. And if the angle is in fourth quadrant, cos is positive. So whenever you are told the measure of the angle, you should be immediately able to tell what will be its sign, whether it will be positive or negative. For example, if you are asked what is sine of 159 degrees, you know that's 159 degrees is 90 degrees plus 69 degrees. That means what? That this angle is in second quadrant. Any angle in the second quadrant, its sine is positive. So sine of 159 degrees will be positive. If you are asked what is tan of 250 degrees, 250 degrees is angle in third quadrant, because angles in third quadrant range between 180 degrees to 270 degrees. And this angle being in third quadrant, its tan is positive. So this you should be able to immediately tell. And it's not necessary that angles have measures between 0 to 360. Okay, if you are asked any bigger angle, say minus 630 degrees. Now minus 630 degrees, this angle, when you find in which quadrant that angle lies, then you can see that minus means it is a clockwise rotation. So it will be one full rotation, that is 360, and still we want to go to 630. So 630 means what? 630 is itself divisible by 90. So this is a quadrantal angle, and its terminal arm will be on y-axis, positive direction of y-axis. And so if you take a point on y-axis, say 0, 1, because what is the procedure of getting sine, cos, tan, that means all trigonometric ratios of any angle? What are you doing? You are taking point on a terminal arm of that angle. So here you can take any point on positive side of y-axis, say it is 0, 1. Okay, so your x will be 0, y will be 1. And so sine of minus 630 degrees, you can easily say that it is y upon r, but here r is 1. Because the point that you have taken, its coordinates are p 0, 1. It means its distance from origin is r, which is 1. And so sine of minus 630 degrees is y upon r, so it is 1 upon 1, so it is 1. But cos of minus 630 degrees, it will be x upon r, so it will be 0 upon 1, so it is 0. But when you go to tan of minus 630 degrees, it is y upon x. Here y is 1, x is 0, so it is not defined. Like that we have to decide the trigonometric ratios, because this particular, when you take quadrantal angles, you cannot apply the rules of angles in a quadrant. Here you have to, because the point is on y-axis, positive direction, you can say that both x and y are positive, r is also positive, so all the trigonometric ratios will be positive, but the tan of that minus 630 degrees is not defined. Like that, you have to tell about the signs of the trigonometric ratios. Also, you have to remember one thing, that sine and cos, these, as I told in the last audio, that sine function, cos function is bounded function. It means for any x belonging to R is a set of real numbers, sin x and cos x, these two trigonometric functions, they are bounded. It means what? You know that minus 1 less than or equal to sin x less than or equal to plus 1. Similarly, minus 1 less than or equal to cos x less than or equal to plus 1. So sin x and cos x are bounded functions. Okay, so if you are asked to calculate, some equation is given, this is what is done. Some equation is given in terms of sine, cos, etc. And you are asked to calculate what is the value of cos theta, what is the value of sine theta, etc. For example, suppose you are asked, if 6 into sine square theta minus 11 sine theta plus 4 is equal to 0, then find the value of sine theta. Now what can be done here? 6 into sine square theta, this is a quadratic equation, right? 6 into sine square theta minus 11 into sine theta plus 4 is equal to 0. What you can do is put sine theta is equal to x. Then the given equation becomes 6 into x square minus 11 into x plus 4 is 0. You can factorize this, because this factorization of quadratic equation you have studied. Solving quadratic equation is not a new thing for you. You have done it in 10th standard. So this quadratic equation, when you solve, what you get is 3x minus 4 is the one bracket and 2x minus 1 is another bracket, 0. It is equated to 0. So from that you get x is equal to 4 upon 3 and another value of x is 1/2. Out of that, 4 by 3 is not less than 1. See, 4 by 3 is greater than 1 and sine of any angle cannot be greater than 1. So that value is to be discarded. And you get another value which is there, 1/2, that will be the sine theta. So sine theta is 4 by 3 cannot be the answer, because any angle you take, sine and cos will always lie between minus 1 and plus 1, or it can be at most equal to plus 1, at least equal to minus 1. And that is why sine theta is 1/2. That is the answer that we can write. So here we are using the fact that the trigonometric functions, sine and cos, they are bounded. Another quality of trigonometric functions, because in functions and relations I told you that domain of the function is very, very important thing. So what about domains of all these trigonometric functions and ranges of all these trigonometric functions? This is very important part of trigonometry. See, domain is that set on which you are operating that function. So trigonometric ratios of an angle theta measured in radians are also called as trigonometric functions or circular functions. Now what are their domains and range, that we will discuss. Okay, we have this fundamental identity, sin square theta plus cos square theta is 1. It means we are saying that addition of two non-negative numbers is 1. And as the addition is 1, each of them must be, because they are non-negative. It will not happen that sin square theta is minus 5 and cos square theta is 6. So addition is 1. It is not possible. Because sin square theta cannot be minus 5. It cannot be less than 0. Because it is a square of a real number. So it gives you sin square theta is less than or equal to 1 and cos square theta is also less than or equal to 1. So that tells you minus 1 is less than or equal to sin theta, less than or equal to plus 1. Same story for minus 1 less than or equal to cos theta, less than or equal to plus 1. That means sin theta and cos theta exist for all values of theta. Okay, so whenever I talk about sin theta, its domain is set of all real numbers and its range is closed interval minus 1 to plus 1. Then when you talk about cos theta, again domain of cosine function is whole set of real numbers and range is closed interval minus 1 to plus 1. When you take tan theta, now tan theta is something which is not bounded. You know, tan theta, if you take that point Px comma y on the terminal arm of that angle theta, whose measure is theta, then tan theta is defined as y upon x. If x is not 0, that is tan theta does not exist whenever x is 0. That is whenever the point on the terminal arm or whenever terminal arm lies on y-axis, tan theta is not defined. The values of theta for which the point Px comma y lies on y-axis are what? Plus or minus pi by 2, plus or minus 3 pi by 2, that means 270 degrees, plus or minus 5 by 2, etc. In general, tan theta does not exist for theta is equal to odd multiples of pi by 2. This is very important. Tan theta does not exist when theta is 2n minus 1 into pi by 2, where n is a integer. So, what is the domain and what is the range of tan theta when you are asked? Then we can say that domain of tan theta is whole set of real numbers except the points theta is equal to 2n minus 1 into pi by 2, where n belongs to integer set. And what is the range of tan? It is whole R. Same story for cosec function. Cosec is 1 upon sine. 1 upon sine is the cosec. And so wherever sine theta is 0, cosec theta is not defined. Now where sine theta is 0? It is 0 when theta is 0 degrees, plus or minus pi radians, plus or minus 2 pi, etc. It means the cosec theta does not exist for theta is equal to n into pi, where n is an integer. And you know that minus 1 is less than or equal to sine theta, less than or equal to plus 1. And so whenever I take its reciprocal, which is cosec theta, then its domain will be whole R except the points theta is equal to n pi. And the range of cosec function will be all the real numbers minus open interval minus 1 to plus 1. Now when you go to sec theta, you can easily, using above techniques, you can easily find that domain of sec theta is whole R except the points theta, where theta is 2n minus 1 into pi by 2, that is odd multiples of pi by 2, and its range is R minus open interval minus 1 to plus 1. And finally, when you come to cot theta, it is reciprocal of tan theta. So cot theta will not exist when tan theta is 0. So you find where tan theta is 0. Tan theta is 0 when theta is 0 plus or minus pi plus or minus 2 pi and so on. Okay, that is why domain of tan theta is whole R except the points theta is equal to n pi. N belongs to integers and range is whole R. So this is the discussion about domain and codomain. It means actually range of these functions. So we can in nutshell we can say that domain of sine and cos, both these functions, is whole set of real numbers, and range of these functions is closed interval -1 to +1. When you come to tan, the domain of tan function is r minus odd multiples of pi by 2 and range is r. When you come to cosec, domain is r minus n pi, where n belongs to integers, and range is r minus open interval -1 to +1. When you come to sec theta, domain is r minus odd multiples of pi by 2 and range is r minus open interval -1 to +1. When you come to cot theta, domain is r minus n pi, where n belongs to set of integers and range is r. So this is very, very important part of trigonometry. Domain and range of all the trigonometric functions we have discussed in this audio. I hope you enjoyed this audio. Thank you.